Imagine diving down into a tropical coral reef, surrounded by vibrant fish and colorful corals. Nestled in the sand or wedged into the reef itself, you spot an enormous shell that looks like it's straight out of a fantasy movie. This is the giant clam, one of the largest and most fascinating bivalves in the ocean. With their immense size and brilliant colors, giant clams are true wonders of the sea. Today, we're taking a closer look at what makes giant clams so unique, from their impressive size to their vital role in coral reef ecosystems. Let's start with what makes giant clams so, well, giant. Giant clams are the largest living bivalve mollusks, capable of reaching lengths of up to 4 feet and weighing over 500 pounds. These clams grow slowly but steadily, sometimes living for over 100 years. They begin life as tiny larvae, drifting in the open ocean, but as they mature, they settle on coral reefs, where they'll spend the rest of their lives. Once a giant clam attaches to the reef, it's there to stay as it becomes too heavy to move. One of the most striking features of giant clams is their vibrant colors. If you've ever seen a giant clam up close, you'll notice they can display a range of colors, including electric blues, vivid greens, and even deep purples. These colors come from symbiotic algae called zooxanthellae that live within the clam's tissues. This relationship is a perfect example of mutualism. Both the clam and the algae benefit from each other. The algae provide food for the clam through photosynthesis, while the clam provides a safe, sunlit environment for the algae to thrive. But how do giant clams actually feed? Giant clams have two main ways of obtaining food. Firstly, they use their symbiotic algae to produce energy through photosynthesis, much like how plants generate energy from sunlight. The clam's bright colors actually help it capture sunlight, which the algae need to produce nutrients. This process allows the clam to rely on sunlight for a significant portion of its food. In addition to photosynthesis, giant clams are filter feeders. They draw water in through a specialized opening called a siphon and filter out tiny particles like plankton. This dual feeding method makes giant clams uniquely adapted to their environment, allowing them to survive in areas with limited food availability by making the most of the sunlight and nutrients around them. Giant clams are not just passive residents of the reef, they play an important role in maintaining reef health. As filter feeders, they help keep the water clean by removing excess plankton and particles that can cloud the water and harm corals. Their shells also provide a habitat for small marine organisms, which can live in the crevices of the shell. In this way, giant clams act as miniature ecosystems within the reef, supporting a variety of marine life. One of the most interesting things about giant clams is their adaptation to sunlight. Since they rely on their symbiotic algae for energy, they have evolved to open their shells wide during the day, allowing as much sunlight in as possible. Giant clams can adjust their position slightly to get optimal sunlight, and their flesh contains specialized cells that help them avoid sunburn while still absorbing light. This adaptation is crucial for their survival, as it maximizes the energy they get from photosynthesis. Despite their impressive size and resilience, giant clams face significant threats in the wild. Overharvesting for food, the aquarium trade, and their shells has led to declines in their populations in many areas. Giant clam meat is considered a delicacy in some parts of the world, and their colorful shells are often used in jewelry and decorations. Conservation efforts are essential to protect these gentle giants and ensure that future generations can enjoy their presence on coral reefs. Another major threat to giant clams is climate change. Rising ocean temperatures and coral bleaching events can harm coral reefs, which are vital habitats for giant clams. In addition, ocean acidification makes it more difficult for these clams to build and maintain their massive shells, which are made from calcium carbonate. As the pH of the ocean decreases, the availability of the materials they need to build their shells also decreases, making them vulnerable. Fortunately, there are ongoing efforts to protect and restore giant clam populations. Some marine reserves and protected areas help safeguard giant clams from overharvesting, and organizations are working to raise awareness about the importance of these animals. In some regions, scientists have even started breeding giant clams in captivity and reintroducing them to the wild, where they can continue to play their essential role in reef ecosystems. Before we wrap up, let's recap. Giant clams are not only the largest bivalves in the ocean, but also some of the most colorful. They rely on both photosynthesis and filter feeding to survive, and their partnership with symbiotic algae is key to their unique lifestyle. By helping to clean the water and providing habitat for other organisms, giant clams contribute to the health of coral reefs. However, they face serious threats from overharvesting and climate change, making conservation efforts critical for their survival. Thanks for watching. If you enjoyed learning about the amazing world of giant clams, don't forget to hit that like button and subscribe for more ocean explorations. And let me know in the comments, would you like to see a giant clam up close on a reef, or would you prefer to admire them from afar?